3, 2, 1. All aboard? Good afternoon, evening, morning, etc. I am here live on YouTube. Maybe someday on YouTube TV. I hear this is a new thing. This is a bonus session of The Coding Train. The Coding Train, where a weekly live stream online internet thing, I hope you can hear me, where I, Daniel Schiffman, something like that, comes online to talk about programming and creative coding and making stuff with code and computer things. And I see myself, oops, nope, okay. And so welcome. This is a bonus session. My typical, please, especially in the Slack chat, which I've got on my eye on right here, please let me know that everything looks fine and that you can hear me and that things have started okay. I see in the YouTube chat that I seem a bit low key. You know, it's been a long day here on the train. I haven't been on the train. I've been waiting for the train, running to catch the train. The train was far away. I kept running. I couldn't catch it. I don't know. It's been a long day. I'm kind of tired. And I'm not so sure this thing about having a bonus session was such a good idea. But I said that I would do it last week, and I was going to do it on Tuesday, and things were so crazy on Tuesday. And then I was going to do it on Wednesday, and things were so crazy on Wednesday, and then I was going to do it on Thursday around noon, and I couldn't get it together to do that. So it's like, I'm kind of like, tomorrow morning is the usual time. So if I'm going to do a bonus session, this is the only time right now. So I'm seeing some people that things are a bit laggy, but hopefully in the chat, but hopefully it's just sort of other people's internet connections. So I'm going to keep going and hope that things kind of like clear up and start working. Okay, so what am I here to do today? So tomorrow morning, Eastern time, Friday, March 3rd, will be the usual weekly live stream around 10:30 or so Eastern time. And one of the things that I have been that I have a set of tutorials about are physics engines. And so what I wanted to do, and a lot of these videos that I made about physics engines were made quite a while ago. So what I would like to do today with this bonus session is talk about physics engine and why you might want to use one, why you might not want to use one, what they are, what are some options, that sort of thing. And then, and so the physics engines that most of my examples are made in, and the other video tutorials that I've made are using a physics engine called Box2D and another one called ToxicLibs. So I want to look at a new one today that was suggested to me called Matter.js. Whatever. My sound effects are working a little bit better today, but I don't really. I need a whole new set of them to really. So many dreams. I have dreams. Late at night, when I lie down to go to sleep, I dream of sound effects. A sound effect for every moment that might happen on a live YouTube stream. I dream of soft sound effects and loud sound effects that don't have errors, glitches in them. Anyway, so I've got to get started, but before I get started, I would like to continue the Coding Train storybook, a million random digits. I've really overused this lullaby music. Let me find where I last left off. I'm sure I'm going to find it. I think it was page 4. I really need some sort of progressive lenses or reading glasses or some kind of like surgery. Okay. 19,612, 78,430, 11,661, 94,770, 77,603, 65,669, 86,868. Ooh, that's a good number, 86868. It's right in here in the table of digits. 12,665. 30,012. 75,989. Tune in next time on the coding train. Next time on the coding train, 39,141. 77,400. Previously, whatever. Okay, so please turn down the music. Oh no. Do I really not have my levels set well? This is terrible. Okay, now that I've lost almost all of my viewers, I'm ready to do some coding. So let me see here. I am going to take a look at, so let me try to find, okay, so what am I here to do today? I'm going to look at the Nature of Code book, and I am going to go, actually, you know what, I want to see what, let me not go here actually. Let me go to YouTube, Schiffman. And what I want to look at is, I'm going to go down here and I'm looking for Nature of Code, Simulating Natural Systems with Processing. And I'm looking for a playlist, Chapter 5, Physics Libraries. So what I want to do today is I want to augment this particular playlist. And if we see here, I have videos about a physics engine called Box2D. And I have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Apparently I have 12 of them. Wow, when did I have time to do that? And then I have some videos about a physics engine called ToxicLibs. And I have, I don't know, and then I have a coding challenge. So here's what I would like to do. I would like to do 3 things in an hour and 20 minutes. Number 1, an overview of what physics engines are, how they work, what some examples of physics engines are, and some differences between them. That's number 1. Number 2, a step-by-step intro tutorial to the physics engine called Matter.js, to make a very basic example that involves the pieces, geometry, bodies, constraints, that sort of thing. And I actually don't know Matter.js, so this is going to be, what are those, I feel like people, there's like people who play video games on YouTube, right, who have, you know, hundreds of times more subscribers than I do, thousands of times, tens of thousands of more times. They have these like let's play videos where they just sort of play through a game. So I'm kind of thinking of this as like a let's code. Like I don't know how to do this. I'm going to try to figure it out. You're going to watch along. So that's number 2. Learn Matter.js and teach it at the same time. And number 3 is do a coding challenge with Matter.js. And I was thinking of trying to make Plinko. Where's my Plinko sound effects? Anyway, so that's my plan for today. Somebody in the chat that I cannot pronounce the name says, would you teach Pixie.js? Yes, I absolutely would. So I have a lot of like administrative stuff to talk about, which is I have some new systems for suggesting topics, and I like to share work for the community, but I'm going to save all of that for tomorrow morning, 10:30 a.m. Eastern time, which honestly usually means around 11 because I'm always late, but I'm getting a little better at getting the setup going. So I'm going to save that stuff for tomorrow. Okay, I am going to have a sip of water because, as you all know, Coding Train, brought to you by water. Stay hydrated, everybody. Okay. Also, can I get some air conditioning in here, please? New York University. I haven't figured out how there's a whole thing, there's a thermostat over there, and I press buttons on it. It never seems to get cooler, but just over time, as I'm in this room, the temperature goes up. I'm in Fahrenheit here because I live in this country where we have this like ancient system. And it said 72 degrees a while ago. Now it says 74. I might have to, the sweatshirt's a little bit hot. Okay. I am so me in the chat asks, have you considered learning a topic before teaching it? That is a wonderful question. Yes, I have considered it. And I always think, boy, it'd be really good to look into this before I hit that broadcast button. But you know, it's very hard. The subway takes a long time. I was stuck on it for at least 15 minutes this morning. So anyway, all right, here we go. That camera went off. I'm gonna fix it up. And I'm gonna press a button over here on this camera, and I'm going to get started with topic number 1. Physics engines. Okay, here we go. Krister. Krister in the chat says, I did send you that Plinko on Twitter. So if you are who I think you are, you sent me a pull request to my randomizer with an example of Plinko, and it is awesome. And I just haven't had a chance to merge it in yet. Nothing other than just like sort of email inbox fatigue. But I will. I looked at it. It's wonderful. I will. And it sort of gave me the well, somebody had mentioned Plinko to me, I think, before, and then I mentioned it. Then who knows where the idea came from? But I looked at it, and it is a big source of inspiration for what I'm going to do today. I don't know if you use a physics engine for that, or you just kind of custom did physics stuff in your own code, but I would love to know. Okay, here we go. Oh wait, so what do I need? What do I need for this first? I think this is going to be a whiteboard video, which I don't know if anybody's going to want to watch it. But I'm going to just talk about physics engines and kind of write some names of physics engines on the whiteboard and talk about which ones do which things. And then maybe what I'll do is, at the very least, let me open up processing so that if I want to come back to the computer and demonstrate some examples, whoops, I could do that. So let me just see if I have, where do I keep all my examples? Okay, here. Let's give you guys some.
As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot, son. This dot, this dot. This dot, never forget this dot, this dot, this dot, this dot, this dot, son. This dot, this dot, this dot.
Ooh, let's see if this will work. What's the chance this works?
This dot, this dot. I'm gonna do this dot, I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot.
There we go. What I'm doing right now is I am grabbing a processing library that uses a physics engine called. Yay, this worked. Amazing. So this is an example using a 3D physics engine that I will mention. And whoops.
Never forget this dot. I'm going to do this dot, this dot, this dot, this dot.
Where's that example? Oh, here,
never
hold on.
forget this dot.
Oh, Shift Command O. That's where I need to get to that. And then I want a good example to demonstrate toxic libs. This is a good one. Interesting. Hold on. So one issue is that I need to, what I'm dealing with right now is the fact that a lot of these examples I've recently updated and changed things, and I'm using a newer version of the library, so it's good for me to, so what I want to do is remove toxic libs entirely, because there is now a new version of the library, which I'm going to install through here. I apologize that I'm not really talking through everything that I'm doing right now, but I will get back to it. Okay, so this should work. Excellent. So this example is working. Great. Yay. Toxic libs. So I have and then I want to open up, oops, I still keep going to the wrong place. I want to get a box2D example open to look at in case I want to. What's a good one? Maybe, I had a bridge one. Oh, that's an exercise. Let's open up, let's take a look at this one. Yeah, I kind of like this one. This one's kind of good. Okay, so this I think is going to, I have a box2D one. Let me just look again. I might want to show a different box2D example. don't remember doing this. Did I do this or did somebody else? Oh, look at this. Oh, I love this example. Did somebody pull request this or did I make it? This is an exercise in the Nature of Code book, which is to make a car. And I'm trying to I just want to look at this code. This kind of looks like how I would do it. I guess I could look at the mystery of the GitHub repository. If somebody wants to look at the history, the GitHub history of that repository to see if somebody pull requested this example or if I actually made it years ago and I just don't remember it. But I love this example. Okay. All right. Ooh, that would be a great coding challenge. Okay. All right. So I am now, think I have a bunch of things. And now what I want to do is I want to go to Matter.js. And what are some other physics engines I want to mention? Canon.js. Let's see, demos. So this is a good one that I will mention. And what else do I want to mention? Matter, Canon, Box2D. Let's just see if there's a Box2D demo. I can probably just look for the... there's like a web demo for Box2D that I have seen. Box2D, excuse me. This is interesting. Oh, look at this. Look at this. This is so interesting, using Box2D, 2D Box2D in a 3D environment, which is kind of interesting. Okay, why? Oh, this is what I'm looking for, I think. All right, this is not important because I have my own Box2D examples. Okay. By the way, this is for all of you patrons in the Slack channel. Thank you, patrons, for your support. That's the party parrot. Okay. So what I'm going to do is, here's a little experiment. What I would like to do is do my overview of physics engines. It's not 4:30 yet, is it? Okay, I'm going to do my overview of physics engines. I'm going to come show a bunch. I want this to be like 10 or 15 minutes, kind of max, and that for me probably means like an hour, but I'm really going to try to keep it kind of like a general overview. And then I will take questions about physics engine. So Mathieu, who's going to edit this later into a tutorial, couple things. This will go in that chapter 5 playlist, and actually it can go at the beginning, because I think I'll mention what's going to follow in the playlist. And then number 2 is I will stop at the end, but it won't be the end. I'll stop to pause to accumulate a bunch of questions from the chat, and then I'll answer those questions. And then I can get edited into a video that gets uploaded separately. Okay? So that's my plan. Any last words for those of you who are watching? For those of you who are watching in the, hold on. Why is this not scrolling? You guys are really... I don't know which chat is more readable now. Okay. Okay. Little ginger tea. And now I've just got to begin. Okay. So what's a good, I think what I will do is, which one of these examples is good to have? Well, let's just have this one. Whoops. Let's make this bigger. I'm sorry, I'm like sort of doing worthless things right now. This example is also the one that I kind of know the least about, but I did make it using a processing library. Okay. So this will be the beginning. I'm really emphasizing the 3D. This is a bad idea because I have so little 3D. Let me use as my visual reference for the beginning of this a different one. Boy, do I like to waste time. I'm surprised that any of you can tolerate. I love this one. This is my favorite kind of physics thing in a physics engine is a Box2D revolute joint. I love those. Okay, and I'm going to do this, and there we go. Okay, this is good. Okay, here we go. And now I'm really going to get started with this video. My kingdom for a box of tissues. I really got to remember to bring a box of tissues. Or a kingdom. It would be nice to. I don't know. I'm not interested in that kingdom thing. Castle would be nice to have. Okay, here we go. Hello, welcome to the first video in a playlist about physics engines. Now, strangely enough, this video that I'm making right now, that you are watching, because somehow you are, is made in 2017. But the next videos that follow in this playlist were made several years ago, and those videos cover two specific physics engines, Box2D and Toxic Libs. So what I want to do in this video is kind of make a little update to what's the state of physics engines today, what are physics engines, what are some example physics engines that you might be interested in, what are some of the features of them, how do they work, and then if you keep being interested, you can continue and watch some of the more specific tutorials. At the very end of this playlist, you'll find some new updated physics engine tutorials with some newer physics engines that I only started recently looking at, most notably a JavaScript one that runs in the browser called Matter.js. This is an example of a processing sketch, a computer program, drawing graphics to the screen and using a physics engine behind the scenes to figure out when do things collide, what should they do after they collide, all of the motion and animation, the location, position, velocity, angle, all of the stuff that's telling me what to draw in this canvas is in the physics engine. That makes no sense whatsoever. Let me try to make this make sense. Okay, so if you've watched any of my previous tutorial videos, one of the many programming tutorials, this is a thing that I do. I have a variable, let's say I'm writing code in JavaScript. I have a variable called x, maybe. And then somewhere in an animation loop, like the draw function in P5.js, I might say something like x equals x plus 1. And what that gives you is, if I want to draw something at that particular x location, maybe at a y location of 100, if I increment its location every frame, it's going to start to move. This, in a way, is a physics engine. What's the world of physics? It's a very simplistic world. Things can only move at a constant velocity on one dimension by 1 unit every moment of time. But ultimately, this is a physics engine. Now, if you followed some of my other tutorials, I start to add in a lot more things, like a y, and maybe I start using a concept called a vector, whether it's a p vector in processing or a p5 dot vector. And then I'll start to have things like, oh, there's a position, and there's a velocity, and there's an acceleration, and there's a force. And so, and then acceleration goes into velocity, and velocity goes into position. All of this kind of stuff to formalize and encode a framework, a system for how things move around a computer screen, modeled off of the way things generally pretty much move in the real world. You know, lots of scientific caveats aside. So this is the trajectory that you'll find if you go back and watch a lot of my Nature of Code video tutorials, or even a lot of the coding challenges where I'm moving and animating things in a computer graphics window. Now, what if someday, you know, this will get me pretty far and is actually a really nice way to work, because I have total control to invent my own creative take on physics and different kind of behaviors, and make creatures that have thoughts and desires and all sorts of things. It leads you to do a lot of exciting, interesting things. But there are moments where you might think to yourself, ugh, all of this vector math, and I got to do collision, and suddenly, you know, I want to know what happens when this strange polygon collides with this circle, and does it bounce off this way? You know, you start to go down this road, and suddenly you're, you know, spending years of your life developing these very elaborate, sophisticated algorithms to figure out how to make things move based on physics. And these are not new problems. And so there are libraries, frameworks that you can import into your code to eliminate the need for you to write the lines of code where you add velocity to position or add acceleration to velocity. And all you do, the way that a physics engine generally works, is you can think of this as the physics engine. It's a box, and in some ways it's a black box. You don't have to know how it works inside to make use of it, although that, you know, it's kind of hard to just use one without some of this basic sensibility and having done some of this yourself to understand about forces and vectors and all that kind of things, because these concepts are all embedded in physics engine. But if you have this black box, you have a moment writing in your program, like the camera's over here, but I'm over here, can you see me? There's a moment where you have your program starts, and you say, hey, world of the thing that I'm making, I would like you to have some circles floating at the top of the screen, and then maybe a rectangle at the bottom, and then you should have this little like spinning wheel, and then I'm just going to say go. So the idea with a physics engine is that you have this kind of setup where you tell the world what should be in it. You say, I'm out of the camera. I really have to, time out. I need a break. I feel like, looking at it, I feel like this isn't making any sense, but I'm going to keep going. This is going to be edit point there. I need to just be more aware. There's like a thing here that I constantly trip over, and then I didn't realize that when I'm standing over here, I'm completely out of the frame. So what I'm going to do, this is probably a terrible idea. Okay, that's a little bit better. Now I can stand over here. Is the focus still okay on the whiteboard? Can you actually see it? Let me zoom in on it to see. Did that do it? No, it didn't do anything. Looks okay. Okay. Okay, I'm coming back. Camera in motion, yes. Okay. It'll be a little weird, awkward edit, but I think it's good for me to fix this because I kind of want to like stand here to talk about this. Okay. So in setup, you might say, here's what I imagine the world to be. It starts with, and one of the coding challenges I hope to do that'll be in a future video is Plinko. So I want to have, you know, a bunch of static knobs in the window, and then I want to have a thing that's at the top, and then I want to have some buckets at the bottom. This is such a weird example, okay? So it's all about, in setup, is saying, here's what's going to be in the world. Then you tell the physics engine, here's all the things, here's where they are, here are their sizes, and then you say go. And then there's this animation loop, the draw loop in processing or P5, every moment in time. And what you do every moment in time is you say, oh, physics engine, where is the stuff? So you set up where all the things are, all of the things of like moving the stuff around, checking if it's colliding, and then if it's colliding and velocity changes this, all of that is done inside of this so-called black box, the physics engine, and your only job is to say, where is everything? Now I would like to draw it. So this is the paradigm that you'll find in physics engine after physics engine. And there's a bunch that I want to discuss and talk about. So let me make a list of different physics engines. We can talk about some of their features. So Box2D being one of the more famous well-known physics engines that's behind a lot of well-known games like sort of 2D mobile games like Angry Birds, fill in all the other ones after that. Box2D. There's a physics engine, and actually something called Toxic Libs, which is processing. What started specifically for processing, a Java library, and it's actually a much broader library beyond physics. But one of its components is a simple physics engine. What else? There is something called a Bullet, which is a physics engine specifically for 3D. There is a physics engine that I want to look at called Matter.js. Canon.js is another one that I recently found, and the list goes on. So I'm sure I'm missing, your favorite physics engine or a really good one, or one that's really useful in this particular context or for this particular programming language. But this is a list of ones that I know something about or that I find useful in some context whatsoever. So let's talk about some things about them. So first of all, language support. So what programming language can you, so a physics engine, what programming language is it written in? What programming language can you use it for? So Box2D, the original Box2D, I think created by Aaron Kato, is written in C++. But there are many ports of it. There is a Java port of it, which allows you to use it in processing, which are my examples. There are many implementations of it in JavaScript. There are several of them. It's a little tricky in some ways to use. It's tricky to use. Box2D is just tricky to use, regardless. But there are lots of ports to it because it's such a prominent and ubiquitous in many ways physics engine. Toxic libs was written originally in Java, so it's useful for Java and processing, and there's a processing library for it. And then there also is toxiclibs.js. So there is, I don't know why I'm writing this again, there's a JavaScript version of it. Bullet is also, I believe, a C++ engine, and there is a Java version of it, which then there's also a processing library of it. Matter.js, these are JavaScript-specific physics engines for use in the browser. So on the one hand, you can think of the question of, well, which physics engine do I want to pick? It's kind of like, well, am I working in processing? Am I working in the browser? Am I working in P5? That sort of thing. Okay. But perhaps more importantly, we might start to think not about language, but about kind of some of the features. So one thing that you might consider, or you over there, are you watching? Did you run away? I would totally understand. One thing that you might consider is whether you can do this in 2D or 3D. So Box 2D is, you might have noted by the name, is 2D only. 2D. Toxic libs has both 2D and 3D physics. Bullet is a 3D physics engine. Matter.js is 2D, and canon.js is 3D. So I don't know why they all get an exclamation point, but they're very excited about their number of dimensions. I am a 2D physics engine. So that's one thing that you might want to think about. Now the other, I had an eraser here. The other thing you might want to think about is, I forgot what it was. I was on a train of thought, and it was going somewhere. And now I'm going to take a break for an edit point. I'm going to come check the chat. Is there a thin black border? Where are you seeing the thin black border? I wonder what that thin black border is. I kind of want to just start this video over. I don't really like how it's going. I feel like on the stream. Well, I don't see it in my anywhere, so I don't know what that is. On the whiteboard scene. I see nothing in my Wirecast preview. Like just around the edges maybe? Is it a problem or is it, I shouldn't worry about it. It's gone now, okay. All right. Yeah, on the whiteboard scene. Okay, I'm trying to think here. What do I want to do? I see. Yeah, I don't know what that. I don't know why that was there. Probably because I pressed something weird on the camera. I'm not very happy with how this is going. And my microphone is a bit misplaced. Lack of sleep, yes. Huh. My microphone is misplaced? Oh yeah, look at this. Maybe I should try actually hooking it to here. It'll be a little bit better. Okay, I'm going to keep going. This, it's barely noticeable, so I'm not going to worry about it. I have a feeling I know what it is, because I pressed some weird button on the camera when I was moving it around. But I'm just going to not worry about it. Okay, I got to keep going. I got to keep going. I kind of feel like, well, it's fine. This is just going to be what it's going to be. Okay, so another thing that you might think about with physics engines is what features do they have? So, what language, is it 2D or 3D? But really the key thing is features. And actually I realized that this list is kind of useless. I'll leave it there because what I want to just take a moment to talk about is, well, I missed a kind of key piece here, which is if I need to tell the world what kinds of things are in it, well, how do I do that? So what are the kinds of elements that go into the world? So almost all of these physics engines use the same paradigm, which is, and I'm going to use, each physics engine might use a slightly different term for the same thing. But for all these physics engines, there's generally something called a world. So the world is the thing that, the world is the entire world of what the sort of space, the physical space, whether it's 2D or 3D, that the entities that you're going to place into that world live in. And it could have, it could have kind of global properties, like it could have a global gravity. It could have boundaries, where things can't go outside of. So typically, most of these physics engines have a world. The other thing these physics engines have typically is something called a body. A body being an entity that goes into that world. And it might be a circular body, a rectangular body, an arbitrary polygon type of body. And I'm kind of conflating something though, which is Box2D in particular has two concepts, which is a body and then a shape. So the body meaning the sort of singular empty point that's floating, that's moving around through the space, and a shape being actual physical geometry that's attached to it. So we could think sort of, but some of the physics engines that are a little less sophisticated are just, it's sort of the same thing, that body and shape are the same thing. So body and shape. The other thing that most of these physics engines have is something, I'm trying to think of which term to use. In Box2D, it's referred to as a joint. In Matter.js, it's a constraint. In ToxicLibs, it's a spring. And so I'm going to call it just a connection, or I'm going to call it a spring. No, let's call it a connection. And so what I mean by that is, what if you had, as your physics engine, there is a body and it's connected to another body that's swinging like a pendulum? How can you have a constraint or a spring or a joint that attaches two bodies? And it's kind of amazing what you can build just from that. Generically, if I have a way of placing any kind of shapes in the world, connecting them in some way that I want, and then saying go, experience gravity, bounce into each other, interact with the mouse, experience of force, there's a lot of worlds you can create that are quite engaging, exciting, and to play with. So, these are kind of the features, but there's a kind of key thing. I really should have started this whole video. If you're still watching, good for you, because here's the real thing. When do you want to use a physics engine, and when do you not want to use a physics engine? And it's sort of like a strange question, because no matter what, you're using a physics engine. The question I'm really asking is, when do you want to just use your own custom-baked x equals x plus 1 or position.add_velocity, or your own kind of cooked-up mechanic for how things move around a space, versus just use somebody else's mechanic that you get to set up and then reap the benefits of as you draw things? And there's no answer to this question. And most of the time, you're in a sort of in-between space. But there are a couple scenarios that I think are key scenarios when using a physics engine is incredibly valuable. Key scenario number one: collisions, 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 collisions. It's like real estate, location, location, location. Physics engines, it's collisions, collisions, collisions. So if I'm ever working on a project and I'm moving stuff and I'm using steering behaviors and I add some gravity and I've got all this stuff cooked up in my code, and I realize what I really need is for these shapes as they move around to bounce off of each other. This is generally where I want to move towards using a physics engine, because rather than spend hours and hours on Stack Overflow and reading through lots of Wikipedia pages to work out all sorts of geometry, math, and collision detection and resolution, these are solved problems that are built into a lot of these physics engines. So that's kind of arbitrary thing number one. I don't know where I am on this whiteboard, which is to use collisions. Not to use it, to use a physics engine if what you need is collisions. Here's another place. So what reminded me of this is this idea of physics engines having a world, a world that's full of bodies and connections. And so one thing that physics engines are very good at is if you want to build some type of simulation that's based on a connected system. So, some examples of this are cloth simulation. Cloth simulation, how is that a connected system? Well, actually a way, and I have a coding challenge that I'll link to in here that builds a cloth simulation using the ToxicLibs physics engine. But you can think of, well, what is a cloth? What if you had a lot of dots? You're going to have to watch this video for a little bit while I draw a whole bunch of dots. And then what if you connected all of those dots with some sort of springy, elastic connection, joint, spring, and then you pulled on one. And I'll show you a version of this in a minute when I show you some examples. So this is the way, and then you textured it with color or whatever, that sort of thing. So cloth, hair, these types of connected base systems. What if you wanted to make, a cute, cuddly character like this, I don't know, with some ears, and it's sort of like it's soft and it bounces and it jiggles and it wiggles around. Well, you could build this by creating a set of particles, perhaps, that are connected with springs and maybe some interior connections to keep it from collapsing on itself. And that could be the skeleton physics behind this particular character. And there are lots of examples. So the other thing that's sort of key about using physics engines is you don't have, the way you set up the world and tell the physics engine what's in it could simply be a skeleton for what you lay on top of it. You might say, hey, there's a lot of circles in this world, but what you're going to draw are images of birds that are kind of circular. And there's a lot of rectangles in this world, but what you're going to draw are like little cardboard box textures, wood box textures, that type of thing. So collisions is a key thing, and also connected systems. So these kind of soft body simulations, cloth simulations, chain, pendulum, there's a lot of scenarios where this idea, which a physics engine is going to kind of do a lot of this stuff for you. It's a kind of known way of implementing something. Okay, I'm pausing for a second here. Okay. Okay, so what I want to do here is, if thinking about collisions and connected systems, is I want to look at these and kind of think about what kind of features these engines have. So Box2D is like kind of amazing for collisions. So if you want to work with collisions in 2 dimensions of any arbitrary geometry, Box2D does this incredibly well. If you want to work with connected systems, springy, soft body simulations, cloth-based simulations, that type of thing, ToxicLibs does this really well. Now, you can do those kind of simulations in Box2D. The ToxicLibs is really just highly optimized towards this world of particles and springs. And ToxicLibs has no collisions. So ToxicLibs is just a particle spring-based physics engine with no geometry whatsoever. So in this sense, if you want to work with, so these are sort of features here. Bullet for 3D, I actually have really barely any experience whatsoever. I just made one example that uses a processing library for Bullet. But for 3D collisions, you can use Bullet for that. And then Matter.js really, I would say, collisions and connected systems. Looking at it, there's a lot of features for both of those things. So, you kind of, I guess there's a puzzle here, which is I'm working on a project that's, I want it to be in the browser, and I want it to just be a cloth simulation. Maybe ToxicLibs is all you need. Well, I'm working on a processing sketch, and I really need to have, I'm making a 2D game where all the stuff is like bouncing off of it, and it's all these like strange polygons. Well, maybe I would use Box2D. But if I'm in the browser and I kind of just want a very generic physics engine that has collisions and constraints, and then I might use Matter.js. So hopefully, if you actually watch any of these videos and see some of the examples, you'll see where some of the physics engines really shine and where others maybe aren't as useful. One thing I'll say in terms of degree of difficulty, there's a level of complexity that the engine has in terms, which is, if it has a high level of complexity, that's really great in terms of possibilities, but also makes the overhead of working with it so kind of extreme that it's sometimes not worth it. If all you want is like a bouncing ball, you don't really necessarily want to go through all of the rigmarole of importing all the Box2D libraries and learning how all the pieces work, and you've got to set up all this extra code. But in terms of ease of working with, I would say Box2D is probably one of the hardest. ToxicLibs in many ways is one of the easiest, but it's a library from many years ago, and finding the documentation and examples is a bit difficult to do, whereas Box2D has such a large user base. There's a lot of documentation and examples for it, albeit, depending on what environment you're working with, there's not necessarily as much for working with it in the browser. But Matter.js, one of the reasons I wanted to explore it is it has a really nice website with thorough documentation and a lot of good examples. So if I come over here, I'm just gonna, where are we, 4:47? Oh, I spend way too much time talking about this. Maybe I'll redo this tomorrow. If I come over, here. If I come over here, you can see, so this is an example of Box2D running in processing. And one of the nice things about Box2D, it has a concept of a motor. So you can see there's actually the motor is on right now. If I click the mouse, you can see this is a revolute joint. It's actually a way of attaching two things based on like a singular point that one object can revolve around. And so you can see almost like a wheel. You can see without the motor, this kind of seesaw just responds to what's landing on it. But if I turn the motor on, it's going to turn and actually activate and start to hit these circles that are falling from the sky, so to speak. If I go to another use for, this is an example of Box2D, which has something called a chain shape, which I'm using to create this surface. And you can see here that I'm also using revolute joints. I can't remember if I made this example or not, but revolute joints to have the wheels of this car turn and move along this surface. So that's, you can see some possibilities here with Box2D. This is an example of using, these are called distance joints, which are like springs in Box2D, where all these circles are connected, creating this like springy like bridge. And if I click here, I can add rectangles to the system, and you can see they're kind of landing and getting caught on this particular bridge. So these are the kinds of things that you can think about making in a system like Box2D. Now, what else do I have to show you? So in terms of thinking about toxic libs and connected systems, this is actually a toxic libs simulation where it looks like, oh, I've got this like stringy rope-based thing, and I can kind of click on this and grab it and move it. But really what this is, if I were to go into the code just for a brief second and just change this to ellipse p.x, p.y, 8, 8, I'm going to draw little circles there. This is actually what's, this is actually what's going on. So if I zoom in here, you can see that what this actually is, I'm not drawing the lines between them, is these are just a lot of particles, each connected by a spring. So when you pull on one, it pulls on the other. But depending on how I render it, I can render it all as a continuous line, which gives it kind of like a string-like quality to it, a string or rope-like quality to it. I can put this back, and I can display a larger circle at the bottom. And now you can sort of see. Now you can sort of see more what it looks like here with this kind of view. So this is toxic libs, and I could open up another toxic libs example just to show you this idea of like the cloth simulation. So you can see this is a lot of particles all connected by springs, but in a grid with some gravity pulling down, and the two that are just locked and attached to the top. And you can see it has a kind of cloth-like quality to it. And then Matter.js. So here's the website for Matter.js, and you can see what's really nice is just right on the home page, it's showing you a lot of demos of the kinds of things you can do with Matter.js. This is my favorite, these little like car things. Oh, actually that's my favorite. I love this one. I gotta build some of these as like a challenge or something. Okay, so that's a bit of an overview about Physics Engine. I'm doing this as a live stream right now. You might be watching this as an archive video. And so what I'm going to do is now take some questions from the chat to see what I missed and answer them. Okay, so let me see if I can get some questions. I really did not, I really kind of want to redo that. I feel like if I redid that video, I could do it in a much more succinct way. I'm looking at the chat. Anybody in either Slack or people are asking a lot of off-topic questions, which are interesting questions, but I'm not going to answer them right now. Can you use multiple? Okay, so FlipKid MC asks. So actually, let me just type down some of the questions, and then I'll answer them one at a time. FlipKid MC, can you use multiple engines at once? That's one question. Any performance considerations? Oh, that is such a good question. Who I missed who asked that. Sorry. Any performance considerations? These are good questions. Whoops. Hold on. Okay. What is more taxing on the system? Can you make an error game? Is HTML easier than JS? So I'm trying to stick to the physics engine stuff. PH Swimmer. Thank you, Nick in Slack for compiling these for me. PH Swimmer. If you guys see good questions that I'm missing, just repost them in Slack. Chrome extension. Yeah, coming soon. Do you need expensive PC? That's really in the performance category. Different approaches to collisions. Can you show how to add gravity to the objects? Do physics engines only use forces, or can you input? Okay, this is a great question. Oh wait, I didn't see who asked that, but there was a question about forces. So how to use, and I'm kind of going to rephrase the question. Forces with physics engines. That's Philippe. So which is sort of forces? Can you control velocities, interact with objects, etc.? So I'm kind of rewriting your questions, Philippe. Are there any shaders to make it look fancy? I'm not sure exactly what that means, but I guess the question is like, what kinds of creative design can you layer on top of a physics engine? So Albert, visual design with physics engines. Can you control the gravity? How does collision get calculated when you use models that are not generated by mathematics? The models are generated by mathematics. Why does the video say Friday at 10:30? That's because that's my usual time. I'm doing a bonus one. Mapping images as textures. I'm going to cover that in a different live stream. Okay, this is a pretty good. Set of questions. Can you incorporate randomness? That kind of goes with this. Incorporating randomness. There was a question that somebody kind of asked that now I've lost, that popped into my head. Oh yeah, listening. I'm just going to add this because I missed it. Listening to collisions. Do some simulate more accurately than others? That's a great question from Ross. Do some simulate more accurately than others? I don't really know the answer to the question. And that was from Leopold, incorporating randomness. Okay, I think this is going to be good for right now in terms of some questions. Can gravity be pulled to a single point? Well, some of these are great questions. They're getting a little bit specific in the sense of like, oh, let's make an example that does that. But the answer to all these questions is yes. Like, can you do blank? The answer is yes. It's more just like, how much do you have to kind of like hack the existing way the physics engines work, and that sort of thing. Okay, so let me stick with these particular questions. And I want to at least start doing some coding because it's 5 o'clock already. How do they, so flexibility, who asked the flexibility and integration with how flexible are the engines? How easily can you integrate them with code? Okay. Thank you, Nick. Okay. Let me start trying to answer some of these questions. Okay. Oh, this was a bad idea today, but you guys are very nice and supportive. Who asked the flexibility question? Yeah, so this is also, Jonathan in the chat asked, are there abstract uses? That's the same sort of question. Oh, Nick asked this. Okay, great. Are there abstract uses? Okay, here we go. Let's answer some of these questions, so we got to move on. All right, so, okay, I've got a set of questions that came from the chat, but I'm going to try to answer some of them, Some of them might not be answerable, or I might not know the answer, but I'm going to discuss them with you to the best of my ability, and you're going to write in the comments and help people who come back and watch this video later to see other thoughts and perspectives and answers here. Okay, so first question here is from Nick, and I'm combining and rewording some of these questions. So Nick asks, how flexible are the engines and how easily can you integrate them with code? And related to that, Jonathan asks, are there abstract uses of maybe using these physics engines without even computer graphics and drawing simulation? So if we come back to my list over here, I think, let me just, yeah. Sorry, I lost my train of thought. Haha, coding train. If we come back over here, and I think, in some ways there's a different answer for a lot of these questions. One thing that makes Box2D difficult to work with is Box2D is actually, in many ways, it's sort of a silly word to use, but a very pure physics engine. It knows nothing about computer graphics and pixels, and its units of measurements are actually meters, seconds, real-world measurements. Now, there's some nuance to this because it's sort of finely tuned for small units of measurements. But that aside, when you actually do this process of saying where all the things are, you have to give Box2D a set of locations with physical measurements as if it's in a real physical space. And Box2D will tell you where the stuff is at a moment in time, and then you have to convert that back to a pixel space. So in that sense, it's incredibly flexible because it's abstracted from computer graphics at all, and you could actually use it in a program and never draw anything and kind of use it to simulate some aspects of things. It makes it kind of difficult to work with, but because you have to do all this conversion and thinking, and it makes it more complex than, say, Matter.js or ToxicLibs, where you can just give the engine pixel-based coordinates and it gives you back pixel-based coordinates. But it does give it a sort of level of sophistication and perhaps even accuracy, you could maybe say. I mean, I'm not expert enough in the lower level mechanics of all these engines to really say which one's more accurate than the other, but that certainly is an aspect of this for sure. Okay, let me come back and see what the next question is. FlipKidNC asks, can you use multiple engines at once? You absolutely could. I think you're probably asking for trouble in some ways. I mean, I'm sure there are some very unique, interesting situations where that makes sense, but there's enough time and overhead in sort of learning. Well, it's certainly worth learning multiple physics engines, but there's enough specificity to what are the objects that are available, what are the names of all the functions, and there's, each physics engine probably has its own vector object, and you can't give Box2D a vector from ToxicLibs, and you can't give ToxicLibs a vector from Box2D, so you're going to have to be converting. So I'm not so sure that you would really want to do that, but anything is possible because you are the designer of the system and you are the drawer of you're the person rendering the world. So you could give the information to multiple physics engines and try to get stuff out and send it back, input it back into the other ones and do some kind of crazy convoluted thing, but I'm not so sure. One thing I should mention is that you don't actually have to do this necessarily. Matter.js and for example, I know very specifically has a kind of automatic debug view. So you can just say to Matter, here's a canvas. Draw where everything is on the canvas. And it, behind the scenes in its code, has the ability to do that. But my point of view in showing you these things is really to focus on how you draw the stuff yourself, because that's where you can really layer in your own design sensibility. And that's kind of one of the questions here. I'm going out of order here, but Albert asked, can you use shaders and how can you really put your own design? That's a really key aspect of being creative and working with physics engines and making something that's not just looking like a demo. So all of my examples are demos because I'm taking the physics engine and kind of drawing the literal pieces of it on the screen in kind of literal way. I'm overusing the word literal. But I'm just saying what's in the physics engine, let me draw exactly what's in the physics engine as sort of simple geometric shapes. Whereas there's no reason why you couldn't make fuzzy textures and blend modes and do all of your creative drawing using the coordinate and geometry information that's coming out of the engine. Okay, what else do I got here on this question? So this performance considerations is absolutely a big one. So one of the nice things about using a physics engine is that, assuming it's something that's worked on by a lot of people over a long period of time,
all the ones that I'm talking about are open source engines that are, most of them, the source code is on GitHub and have a wide variety of contributors. But probably for, people have been working for years on optimizing them. So in many ways, it's going to be more efficient and have higher performance than what you might throw together in a day. That said, these types of computations are expensive. To look at every object in a system and how it's colliding with every other object, and it's going to have some kind of complex polygon geometry. So, there certainly is a slowness here, but, Box2D is very efficient, runs very fast, especially if you're in C++, but it's going to run a lot slower in the canvas and the browser. Drawing is slower. So, yes, there are performance considerations. Could I sit here and talk about them? I'm asking myself questions now. The answer to that is no. That I think merits a lot of trial and error and digging into the source code and seeing how things work best. Okay. Nick does not deserve credit for the first question. So I don't know who asked that question. It was a great question, but it was not by Nick. Thank you. Let's see. Do some simulate more accurately than others? That's another consideration here. There's usually often a trade-off, right? It's going to be slower if it's more accurate. It's going to be faster if it's less accurate. Apparently that question is from Gabriel, perhaps. Another question here is from Philippe. How to use I reworded this question, but how to use forces with physics engine, and can you control velocity? So this is a big question, which I will cover and look at in a lot of my examples. But the question really is, I kind of set you up in this way of hey, let's put stuff in the world. It's in the world. Now let's go over here. Let's read where the stuff is and let's draw it to the screen. But what if the thing that's in the world, I want to control how it's moving, or I want to add a force into the world that's going to affect the way that the world is behaving? And so most of the physics engines are going to have a mechanic for this. For example, the body object. You create this body object, you put it in the world, you can keep a reference to that body object, and later you might be able to call a function called add force or apply force to cause the body to experience maybe a sudden gust of wind, for example. There's a question though, it's well, what if you want to affect these not with a force, but by actually saying, hey, I want this object's velocity to be this. And yes, physics engines will let you do that because, number one is you can just kind of dig into the source code. Body's going to have a variable in it somewhere that's the velocity. You could set it. But you have to watch out. The big problem here, it's very easy to violate the laws of physics with a physics engine. It's kind of hard to do that, although I would love, that's a good real world challenge. Let's violate the laws of physics. I'm sure that would be an exciting YouTube video and get lots of views. But we can easily violate the laws of physics. For example, what if I just take an object that's in the world and I say, hey, its position is over here. Now set its position to over here. I can actually do that and it's going to appear over there. But what I've essentially just done is I've teleported it, which violates the laws of physics. At least in terms of physics engine. And so in that case, you might start to see some strange behavior. But if I wanted to move something around manually through an interaction without teleporting it to cause some strange behavior, what I might be able to do is attach a connection. Maybe I attach a connection to the object and I connect it also to my mouse, and then I move the mouse around and I'm tugging it around, almost like I've attached a string to something and moving it. So that's one strategy for moving something around through a Perlin noise algorithm or through user interaction by still staying within the sort of laws of physics of that world. So, really this is a kind of it depends on how the engine is working, but this is a common mechanic. Press this button here. It depends on how the physics engine works, but this is certainly a common problem. And that wasn't really a question, I added it to my list. Another very common thing about physics engine is, oh, it's doing all this collision stuff for me. That's great. Yay, I don't have to do the collision stuff. But what I really want is when they collide, I want to bing, play a note of music or something. So if you want to do that, you have to know when the things collide. And that's happening in here. How do you know when it collides? Well, you could say, okay, well, what I'm going to start to do is I'm going to look at all the things. I'm going to look at where they are in relation to each other, and when they're within a certain distance, they must be colliding. But then if you go down that road of thinking, you've completely defeated the whole purpose of using the physics engine. You're starting to re-implement those collision algorithms yourself. So most physics engines will have this idea of a collision listener. So you can write a callback function or create some type of object that sits there and tells you information about, hey, there's been an event, these two things collided, here's object one, here's object two, here's their properties. What are you going to do about it? So you're like, oh, if it's a purple object with a red object, it plays C. If it's a green object with a pink object, it plays the note D. So you're going to want to look for something like a listener to be able to also not just extract where the things are that you want to draw, but to extract moments in time that are certain events, like collision events, that you want to handle in a certain way. Okay, so this is like a ridiculously long intro to physics engines tutorial video that I can't imagine anybody really wanted to watch. But if you're still here, thank you for watching. And I think the other videos in this particular playlist will have much more information and actual code about how to do these things and how they work. So I hope you watch them and I hope you enjoy them. And I'm sure, and I hope you leave me some comments with some feedback. Okay, thanks very much and I'll see you soon. Okay. I don't know. Good thing I did this today. Here's the reason why this was good that I did this today. I got this out of my system. I'm not really happy with it because what I really wanted was just like a 10-minute, like what is a physics engine video. But anyway, hopefully this was useful and interesting to people. And what I'm going to do now, because the good thing is this really saves me a lot of time tomorrow morning, because when I get here tomorrow morning, I can dive right into some more code examples. What I'm going to do, what I want to do now, I still have at least 20 minutes. I want to look at Matter.js and actually write some code. Give me a second to refill this water. I'm going to mute my microphone, and I'm going to play you guys some music.
As always, I always forget.
And I'll be right back.
This dot.
Moving on. Let's all move on. Okay, so what I'm going to do now is I'd like to salvage today and get a little further. And what I want to do is I am going to close processing. I am going to open up the Atom editor. And I am going to make an example here. I'm going to grab one of my P5 and Matter example that I made last week that I have no recollection of whatsoever. And I'm going to put this in here. And I'm going to just paste it to the desktop. And I'm going to type in P5 Matter, Matter dash basics, and I am going to open this in Atom. I'm going to look at index.html, and I am going to take out all the code, and I'm just going to put in setup. And I'm going to put in draw. It's bound to happen sooner or later. Okay, and I'm going to go to bed early tonight. Tomorrow is going to be the greatest live stream ever. And I'm going to say create canvas. And I'm going to say background 51. And I am going to open up Chrome. Localhost, I'm going to go to terminal. And I'm going to go to this example. And then I'm going to refresh Chrome. And I'm going to clear this. Make this a little bigger. Anyway, okay, good thing the camera went off. Let's make this happen. So what I'm going to do is I'm I'm going to look for Matter.js. Okay. And we're going to start this video. Okay. The whole point was I wanted to get some water, and then I thought, I'm getting the water. You know, I might as well just also do the other thing, the peeing thing. I don't know why I can't say it. There we go. Hello. This is a video about a physics engine called Matter.js. I am going to teach you how to use Matter.js. Here's the problem. I don't really know Matter.js very well, so what I'm actually going to show you is me trying to attempt to make a very simple example in Matter.js by reading the documentation and figuring it out as we go. Now, it's not that I've never looked at this before. I have. I made some examples of it previously. I haven't looked at it in a while, but I've certainly, I certainly haven't spent more than like 45. You don't need to know about the amount of time. Let's just get started. So Matter.js is a physics engine. What is a physics engine? If you really wanted to, you could watch a different video that I have that I'll link to in the description where I spent a very long time kind of talking about what a physics engine is. I didn't do a very good job. But anyway, this video is going to be much better. I can tell already. So Matter.js is a JavaScript physics engine. You can see a lot of demos of what it can do right here, just even on its homepage. It's an open source physics engine. You can find it on GitHub. Thank you to the creator and everybody who's contributed to this engine. It's terrific. So you can find the source code, documentation, etc. So most physics engines operate with this idea of having a world. Here's the world right here. That world can have things in it, like shapes, and those are often called bodies, and I think they're called bodies in Matter.js. And also, you can have something that connects different bodies together, and in Matter.js, those are called constraints. So what I want to do is maybe just create a simple example where a couple squares fall from the top of the screen to the bottom and bounce off of each other, and let's just see if we can get that to happen. Okay, so what I have so far in my code is I'm using the P5.js as a library for drawing and animation. I have a setup function where I make a canvas, and I have a draw function that loops over and over again where I set the background. If I go and look at my code, here it is. So what's a way that we can kind of get started with Matter.js? If I go to the home page, let's actually look on GitHub just for a second. So if I look on GitHub, I feel like in the README, let's see. I saw a getting started page somewhere. Install usage. Let's look at usage. Examples. No, wait. Getting started. This is what I'm looking for. So I'm looking for this getting started wiki. So one thing is we've got to make sure that we have the Matter.js library. You can see it up there referenced in our HTML page. And I've done that. So if I look at the if I go back to Adam here, you can see I have an index.html file, which is referencing the P5 library and the Matter library. And both of those are in this library folder, Matter.js and P5.js. So if you want to do exactly this example, you've got to have both of those libraries, the files for them, referenced in your index.html, in addition to referencing my own sketch code. Okay. Now here, following is a minimal example using the built-in renderer and runner to get you started. So one of the things that Matter has is it has a built-in renderer, meaning it will actually draw everything to a canvas for you. You don't have to do it at all. You can even set settings and styles things, but that's an interesting way of working and a really quick way to just try things out. But I'm going to try to build an example where I'm not going to use a built-in renderer. I'm going to use my own renderer, P5, so I can really have total control over the design. Okay, so first thing is module aliases. So what's the deal with that? Let's copy that into our code. You'll see this with a lot of libraries. Module aliases. So why do you have these? Well, a lot of JavaScript libraries are namespaced, meaning they have things you can use in them, like an engine or a renderer or a world or a body. And so, but they're all namespaced under matter.render, matter.world, because what if there was a built-in variable in JavaScript in the browser already called world? You don't want to have a conflict, so you call it matter.world. But every time you want to reference world in your code, you don't want to have to type matter.world, matter.world. So this is a little alias that I could just say, the thing is matter.world, but I want to set world equal to matter.world, so I can type it whenever I want. So that's a quick thing we've got so far. We've got some aliases. And to be honest, this one I don't want. But I'm going to comment that out because I don't want to use it by accident. Okay, let's go back here. Now, engine. So a physics engine is an engine. We've got to say, hey, make the engine. So let's do that. So I'm going to put that in setup. And I might want to have a global variable reference to that engine. And I'm going to do that right after I create the canvas. So I'm going to put that in setup. We're making our engine. This is pretty good so far. Wait, you're watching a video where somebody is copy-pasting code from a browser into a text editor. You realize that's what you're watching right now. Maybe it'll get better. I'm going to skip this renderer thing. Look at this. Okay, so this is exciting. This is showing some examples of how you can create bodies in the world. So there are a bunch of functions. We're seeing just an example of one of them here, rectangle. So I'm just going to do one of them. I'm just going to grab this, and I'm going to make a variable called box, and I'm going to add this now to setup, and I'm going to say box equals bodies.rectangle. Now, here's the thing. I'm going to give myself a little more space here. We could probably guess, right? This function is creating a rectangular body at pixel location 400, 200, probably with a width of 80 pixels and a height of 80 pixels. But let's say we wanted to confirm that that was the case. How would we do this? So one of the things we can look at is if I go to Matter.js and I want to go to documentation. And under documentation, I kind of look at, okay, these are all the different kind of subcategories where there are various functions and objects you can have access to. And constraint is clearly where we're going to make things to like connect. Bounds is kind of interesting. Maybe that has to do with the boundaries of the world. But bodies, if I click on that, bodies has a whole bunch of methods like circle. Circle creates a circle. From vertices, meaning I could pass a list of vertices to get some sort of polygon. This is great. And if I look down in here and try to find rectangle, we can see X, Y, width, height options. So what's interesting about this is there are some options. See the properties section of the matter.body module for more details on what you can pass via the options object. Let's keep looking. This is exciting. Let's do some detective work. So by the way, why am I just saying bodies.rectangle? Remember, it's actually really matter.bodies.rectangle. But that aside. So let's not worry about the options right now. We could dig into that later. Okay, so now I have a box. This is very exciting. Okay, so now what I'm going to do is, where were we? Well, let's keep going with this. What I want is I want a variable actually that also keeps track of the world. And you can see the world is an entity that's part of the engine. So I'm going to create, so I have an engine, which is the whole physics engine itself. And inside that physics engine, there's going to be a world that's full of bodies. So I'm going to make a variable called world. And I'm going to say world equals engine.world, which is maybe a little silly, but I like to sort of organize things in a very organized way. And then I want to make sure the engine runs. So I'm going to say engine.run engine. Now, a lot of physics engines will require you in draw or in your animation loop to explicitly say update. Update each moment in time, or step through each moment in time. Looks like Matter.js doesn't require you to do that. It just says you can just tell the engine to run. And so it's going to be going. And I would assume that there's some way of configuring, how is it kind of like updating itself 30 frames per second, 60 frames per second? What is its measurement of time? So we could probably dig into the documentation, but the default running the engine is probably going to be good enough for us. So what I want to do next is, so now I'm stuck, right? Because I don't want the renderer to do anything automatically. What I want to be able to do here is now, what I've done is I've set up the engine. I've said, make the engine, make the world, put one box into it. And now what I want you to do, please, is every time in draw, I want to ask the physics engine, oh, please, physics engine thing, where is that box? So what we need to look at, so actually, let's just do something here. Let's just say console.log. We could look in the documentation, but one thing that might be nice is just to say console.log box. So let's go back here, hit refresh, and look at this. Oh, you know what? So this is, I've done something rather terrible. It's so nice of P5 to give me this error message. P5, and Alka in the chat writes that the default for Matter.js is 60 frames per second, so that's great to know. P5 had problems creating the global function box, possibly because your code is already using that name as a variable. You may want to rename that variable to something else. So I've done something rather not so good because there actually is a function in P5 called box, and I made my own variable called box. This is why namespacing exists. P5 works very much in the global namespace to keep things simple, so I could just say box. I don't have to say p5.box. But so I'm going to name this Boxy. Box 1. Terrible name. Boxy was better. So now let's console log box 1. Let's run this again. And we can see here's the object. So we can look and we can see, look at all this stuff. Angle, angle previous, angular speed, angular velocity, bounds, axes. There's so much information here. Parent, parts, position. Well, look at this. Position's definitely going to be useful for us. X is 400, Y is 200. So let's make use of that. Let's try saying rectangle box1.x box1.y. Now, could I get the width and height from the box? Now, I kind of have a sneaking suspicion that I'm not going to find any variable for width and height in here. There probably is a variable that keeps track of its vertices somewhere. Parent, no. Axes, no. Where would that be? Render? No, that's for the renderer to deal with if we were using the automatic renderer. Bounds. Where would that be? Max, min, no. Force, density. This is a really interesting video for parts. Pause this video. I'm going to edit some of this out. We'll do a little bit of looking. And then, restitution I want to talk about. Vertices. Oh my God, I'm just an idiot. It's been there all along. Okay. Mathieu, you'll do a little editing there. Oh, okay. Oh, there it is. I looked for a little while there. Vertices. So this I could use, which is actually going to give me the x, y of all of its vertices. But I'm going to do this. There's so many different ways I could do this. I'm going to do this one way right now, which I'm just going to do. I'm just going to do this an awful way, which is I'm going to hard code in the width and the height that I know about. So now let's run this program again. This magical program. I'm going to hit refresh. It's going to be really sad when this doesn't work. Boy, that drum roll was pathetic. So how come I don't see it? I just said .x.y. Remember? What was it in? Oh, that's so sad. I was not being careful and thoughtful here. It was actually called position.x. So I need to look at box1 position.x, box1 position.y. Oh, it's so sad. Let's console log box1.position.x. I put it at 400, 200. I put it somewhere off the screen because I was using its default. Oh, this is terrible. Let's put it at 200 and put it higher up at like 100. Boy, I'm really a terrible programmer. Everybody should go subscribe to a different channel. I do have a snare drum roll though. Hey, there it is. Oh, thank you, my box. Okay. But I'm getting a really, really good. Alex in the chat is making an incredibly good point. I forgot a key piece of this because I got off track. What step am I missing? I need to make the engine. The engine's going to have the world. I need to make the body, and then that body needs to go in the world, right? I need to actually say, hey, that body is something that's going to experience the physics. And if we go back to that getting started page, I'm sure we'll see world.add and then a bunch of things. So this is a way that I can add something. If I unpack this code here, if I say world.add, so this is a generic function add. And you know, it's funny, like I would almost like this to be this. This is what I want to do, which is to say add box1 to the world. But it looks like what's actually happening in Matter is that I have an add function which is namespaced under world, where I give it both the world that I want to add to and the things that I want to add. So I wouldn't be surprised if this, apparently you can give it an array, but what can I just give it a single object? Let's try that. So now let's run it again. I forget that stupid drum roll. Hey, there it is. Woo! So this is what I mean. If all I wanted to do, if this was my project, you know, using, and Matter.js, that was pretty simple to do with Matter.js as a physics engine, but if, yeah, definitely need a sad trombone sound effect. If this was my project, I would not want to go through all of this figuring out the physics engine. I could just have x, y, and say y equals y plus whatever, and then add some gravity and that sort of thing. But what I'm getting here now is, first of all, let me reorganize the code in a different way. So first of all, I want to do something that's going to make things easier for me to manage. I'm going to create a new file. I'm going to call it box.js. And I'm going to write, and I think this should be okay because it's capital box. I'm going to create my own box. And it's going to have a body in it. So my box is going to get an x, a y, a width, and a height. And when I make, so I'm going to make my own object, which is a wrapper for the Matter.js object. So now I'm going to go in here. It's just got a little bit unnecessary, but I think will be nice. So I'm going to grab this code, and I'm going to put it here. So this rectangle is going to be the body associated with this box. And then when I make that body, I also want to remember to add it. So I'm going to put this in the object. And again, there's umpteen ways, and it's not so great that I'm using a global variable here, but there's umpteen ways I could organize the code. This is just one. So I'm going to add the body to the world in the object. And then I am going to write into that object a function called this.show, where I'm going to say pos equals this.body.position. I'm going to ask for the position. Now, I also actually really need the angle, this.body.angle, because that thing might start to rotate as it bounces off of stuff. And I'm guessing it's body.angle, but we'll find out soon enough. And then I'm going to say push and pop. And I'm going to use translate now. So I'm going to get a bit fancier. I'm going to say translate to pos.x, pos.y. And then I am going to say rectangle, pos 0, 0 with height. Now, the funny thing is, this width and height variable is kind of available to me down here, but I don't love the way I did this. I think I want to just put that in. I'm going to add my own, since the body doesn't keep track of its own width and height, I'm going to add my own variable to keep track of that. And let's just see, without worrying about the angle right now, let's now see I've made my own box object. So now I can say box1 equals a new box object that's my own, 200, 100, 50, 50. And then I can say box1.show. So this should be the same program. I always like to do that when I know I've missed something. Yeah, okay. Box is not defined. What did I forget? I added a new JavaScript file. I didn't reference it in index.html. So I'm going to do that right now. I'm going to add it here. I'm going to reference box.js. And here we go. There we go. Look at that. Woohoo! Okay, so now that's working. This is exciting. Now, what do I've got? Let's do this. Let's make this an array. Boxes is an array. Let's take this. Let's say function mouse pressed. Whenever I click the mouse, let's say boxes.push a new box at mouse x, mouse y, and let's make them smaller, 20, 20. And then let's, in draw, I'm going to, I'm almost going to, I was so close to using a for each loop there. It would have made some of you guys so happy, but today's not the day. It'll come someday. And then I'm going to say boxes index I.show. So what I'm doing now is I got that one object working. I sort of packaged all the physics stuff into the object so I could just make a bunch of them. And now, mouse Y is not defined because I spelled it wrong. Now each time I click the mouse, I get a box. Now, can we really see if any physics is going on here besides just gravity? So what do we need to do? One thing I want to do that's really going to make this work is I want to add something at the bottom here that they'll bounce off of. I want to add a ground. So how do I add ground? So I'm going to make a variable called ground. And ultimately, I could also kind of wrap my own object there, but I'm going to be a little bit lazy about this. And I'm going to say ground equals bodies dot rectangle. And then I want this. Now, an interesting question is, does Matter.js consider the center of the rectangle? I bet you that's what it is, or the top left. I don't know. Let's guess it's the center. I kind of have a feeling that. I want my rectangle to be in the middle and at the bottom, and I want it to be the full width and just like 10 pixels high. Because I want to have a body that sits at the bottom that things bounce off of. But I don't want that body to move. So what I want is I don't want a dynamic body. These are box2D terms, but the same concept applies in Matter.js. I want a static body. And I noticed, as we're looking at this getting started page, this is where those options come in, right? If I create a rectangle at this location and I give it an extra option like is static equal true, and so what I'm going to do, I'm going to make my code a little bit more long-winded, but I'm going to say options, and what was it? Is static true? So I'm going to make a little JavaScript object, and I'm sure there are lots of other options I could add here. Options is static true, and I'm going to have the ground be, I'm going to add those options to the ground, and then I need to say world, what was it again? Dot add world ground, was that it? I don't remember. Yeah, that's it. So I also want to add the ground to the world. All right, let's see. Oh, look at that. Ooh, sort of, it's doing something, but it's a little bit weird, right? It's a little bit off. And one thing I want to do just to make this a little bit more dynamic is I want to change this to mouse dragged, just so I can add a bunch at once. Right? You can see them all bouncing, but it's not working, right? Now, first of all, I didn't draw the ground. This is a thing to remember, right? I could do this. Look at this. I could say, hey, make the ground in the middle of the window. There it is. I don't have to draw it. I could now draw a line there if I wanted to, because it's all based on, I could draw a line in the wrong place. It would be crazy. But what's missing here? These rectangles, as they bounce off each other, are going to rotate. And so the nice thing is, I have to assume, now the question is, I can use the rotate function based on that angle. So I can rotate the rectangles based on the angle that I'm getting from the body. Now, is that angle in degrees or radians? I don't know. Let's find out. That doesn't look right. Does that look right to you? Does not look right to you. So let's guess that it's giving it to me in degrees. And let's convert it to radians. Whoops, that's not right either. Where's my sad trombone sound? So let's figure this out. This dot body dot angle. So let's look. Let's look in the console. Boxes index 0. Let's just look at one of them. Oh, whoops. Boxes index 0 dot body. Angle. Though this definitely looks like a radians amount, not a degree. So what did I do wrong? Oh, maybe I'm drawing their reference point incorrectly. Ah, I know what it is. So the rectangle function in P5 draws the rectangle with its reference point the top left. So I need to tell P5, no. The 0, 0 is at the center of the rectangle. Rect mode, center. So this is a really key thing that comes up with working with physics engines. The way you're drawing stuff needs to match the way the physics engine thinks it exists. And it's not just going to work automatically. You've got to really make sure those things match. And obviously, I'm getting things wrong here and there. Okay, so I think that's pretty good. Let me move the world back to the bottom. And let me just draw something along the bottom just to, let's make a line that goes from 0 height to width height. And I'm going to say stroke weight 4 and fill 255. And then what I want to do with the boxes also is be a bit more thoughtful about what they look like. So I'm going to say stroke weight 1, stroke 255, and then fill 127 or something. Okay. So now we can see this looks better. Yes? Yay, I think you can see that they're, okay, so they really are getting kind of like stuck on each other. And I have a feeling I remember, I think this has to do with, okay, hold on. Sorry, pause. Let's have a little edit moment for a second because my phone started to ring and got me all freaked out. Oh, it's 5:45 too. I'm going to wrap this up. I want to do so many more things to this. Make it a slanted floor. That's a great idea. And also, where is I don't see it, the floor. Okay. Why don't I see the floor? Line height, width height, stroke. Oh, stroke 255. Oops, okay, let me fix that. Okay. Hold on. So a bunch of things I want to fix here. So number one is, I'm not seeing the floor. I would really like to see the floor. So I put fill here by accident instead of stroke. So let me put that in. No, because it's white, you can't actually see it. So let me make that like 170 or something. This is silly what I'm doing now. You can kind of see it there. But actually, you know what? I'm being so silly here. This should really be, I should really draw the floor exactly as I made it up here. And so I'm going to be really, really like lazy about this. And I should make an object and do all these things that I did with the other thing. I'm going to make this a rectangle just so it's actually in the right place. Oops. And now yes. So this should also be rect mode a center. There. Now you can see the floor is there. And I have the stroke weight there by accident, which I don't want anymore. Okay. So you can see here, and I actually, let me just do no stroke. Okay, sorry. So you can see there's the floor. So the things are landing on the floor. Now, one thing that's kind of going on here is you can see they kind of like getting stuck on each other almost immediately. And they're also like kind of pushing up against each other. So I have a feeling now this comes down to a sort of moment where what we now need to do is kind of tune the engine to perform the way that I might like it to perform. So I have a feeling that some of the properties that I can add, like affecting its friction or its density or its restitution, are things that I could tweak. So let me look at how I might do that. Now I wonder, let's look at that options again, because maybe we can add those things in options. So in the documentation, it said here, see the properties section of matter.body module for detail on what you can pass via the options object. So let's go to matter.body. Oops, no. Matter, I want matter.body. So that's right here, body. And then I want to look for options. So what are my options? Whoops. I'm looking for the more detailed I kind of know what they are, but I want to be able to see. There's all these things I could do: set mass, set parts, set position, set static, set velocity, translate, update. Oh my God, there's so many things I could do. So there are these properties. The following properties, this is what I'm looking for. The following properties are specified for objects created by matter.body.create and for objects passed to it via the options argument. So these are things I could adjust after the fact. Like when I'm looking for, let's just look for friction, for example. A number that defines the friction of the body. The value is always positive and in the range 0 to 1. A value of 0 means the body may slide indefinitely. A value of 1 means the body may come to a stop almost instantly after a force is applied. So this is actually the kind of thing that I could probably do this in a number of ways. Number one is I could do something like this. I could just say this.body.friction equals 1. So I could do it here. I have a feeling that works. Can you tell if this is different? I don't know. Now I could set it to 0. Let's just see. Yeah, you can definitely tell that that's different. 0 friction versus a friction of 1. That's kind of interesting to see. So, but I could also probably do this again. And this might be a little bit nicer because I can do a bunch of options. So I'm going to say options here. And these don't have to be the same for every. So what I want to do is do friction. And I also want to do, so I'm going to do 0.5, just somewhere in the middle. I also want to do restitution. Now restitution has to do, and I also want to do restitution. So restitution has to do with the sort of bounciness. Like, is this thing that's falling, is it going to land and just sort of land there and stop? Or is it going to hit there and bounce way up because it's very elastic or spongy or bouncy? So let's look up restitution. I'm sure the documentation will explain it better than my botched little whatever thing there. Ooh, air friction. A number that defines the restitution elasticity of the body. The value is always positive, 0, and 1. A value of 0 means collisions may be perfectly inelastic and no bouncing. A value of 0.8 means the body may bounce back with approximately 80% of its kinetic energy. Hey, we got some physics stuff going on here. So let's now, let's give it a restitution of 1 and go back. There, you can see how bouncy they are. So that's like too much. So what I want to do is, I want to move the bottom, just for the sake of argument, to height minus 50. I want to be a little more thoughtful and say ground.position.x, ground.position.y. And by the way, it would be an interesting exercise to like angle the ground. So let's just do that. And now let's do this. And what I want to do there is, there was a little bit of glitchiness there. I want to make the restitution like 0.6 and the friction like 0.3, and I feel like this is what I want. Ooh, why are some going through? I wonder if so I think there's a little bit of an issue here where when I drag the mouse, I'm creating so many objects on top of themselves. And so in this case, just to like look at this in a slightly different way, I think I want to go back to mouse pressed, just so I can look at them one at a time. Oh, why did that happen? They're so bouncy. So that must be doing something a little bit off here. It looks right though. I went, I'm like enjoying my physics. So I think I'm gonna look at this some more and see if there's some other things I need to tune with this. And then I am going to come back. I'm looking at the chat right now because I'm seeing some interesting comments. I'm going to come back and in the next video, I'm going to add a few things to this. Number one thing that I want to make sure to show you how to do is how to add some mouse interaction. So if I want to click on one of these and drag it and kind of toss it around. And I'm also really wondering why those first ones, what I'm wondering here is why the first ones seem to like fall through the ground. Like what is going on there? Oh! It's only over here, no? There's like a little blank space here? I'm gonna have to debug this. Hold on, time out. Does anybody know what's going on? There's a problem with the first box. Render the floor first. The ground is added. It's set to be static. 200 height minus 50 width. The height is 10. And then I'm rendering it at exactly, collision never occurs. Is it the speed? Do they step? So it might be that the time step is too large and they're going so fast that they step over it. So here's something that I could do just to fix that right now, is I could make the height, the size of this ground 100 and position it further down. So it's just coming 50 pixels above. Oh, no, that's so weird. Oh, okay, because I'm drawing it in the wrong place, right? Hold on. So it's, let me be more thoughtful about this. Make the ground thicker, yeah. Height, see, this is terrible what I've done, which is that I have, like, I'm not actually using, so one thing I'm going to do is just as a quick little like hack here. 200 comma height width, oh, silly me. I drew it larger, but not, yeah. So this is definitely behaving better now. Wow, it's really, yeah. Yeah, okay. So hold on, let me come back into the video here. They're all falling through. So, okay. Yeah. So, okay, so there's an issue where is that you're noticing that sometimes these squares are like falling through the bottom. And my suspicion here is that I made the ground this very, very skinny rectangle. And these boxes are actually moving quite quickly by the time they get to the bottom. And perhaps the time step is such that its position at one moment and the next moment kind of skips over it. So there's probably some settings in Matter.js that I could change in terms of its time step calculation. But I want to look into that. But right now, here's a way I could fix this. I could just make it thicker. So just as like to make sure. So I'm going to make the height of it 100, and then I'm doing a very silly thing where I have to type in this hard-coded value in 2 places to also draw it that high. So now I've got a much sort of like thicker ground, so to speak. I have a feeling that even if I drop it from way up high, it's not going to be able to skip over it. So now we're seeing that this physics engine, that this example, this demonstration is kind of working more like what you might imagine. Here's one thing I'd like to do just to make this have a little bit more variety, just so you see it, is I want to go into box.js. And, oh, actually, let me just do this up here. And I'm going to make, when I create the new, I'm going to make it with a random width between 10 and 40 and a random height between 10 and 40. So let's just see, make sure this still works with different sized rectangles. Oh, yeah. It's funny how the first 2 were like squares. So you can see here that this works even with rectangles of varying size. Wonderful. So here is a basic implementation of Matter.js. Really simple. There's a lot of things I could build on top of this. I need to look at how I can drag things around with the mouse. I need to look at, well, how could I make it an arbitrary polygon that's not just a rectangle? What if I wanted it to be a circle? I'm sure you could think of a lot of your own features. So I'm going to do a couple more video tutorials and a coding challenge at some point to build a particular scenario. So thanks for watching this Matter.js tutorial, and I'll see you in some future ones. Okay. I like how Rodrigo in the chat says, describing what I'm doing, he's fooling around with Matter.js and p5.js. That seems very accurate. Okay. Thank you guys for tuning in today to what I'm calling now. I mean, last week it was like the coding train wreck. Now I just think it's the worst coding train ever. But it's good because I'm like back in the mood, the moment. I'm going to leave. I'm going to go take the subway. I'm going to get home and have a good night's sleep. I'm going to be back here tomorrow morning, and I am ready. Look at this. So I'm going to point out what Alka is telling me in the chat in a second, and I'm going to be ready for the best coding train ever, which will happen tomorrow morning. Okay, the correction argument, matter.engine update. Delta and correction. So there are parameters is an optional number that specifies the time correction factor to apply to the update. This can help improve the accuracy of the simulation in cases where delta is changing between updates. The value of correction is defined as delta divided by last delta. So this is probably under matter.engine. So I could probably fix this. So if I looked at this here, wherever I'm saying, where am I saying that? Engine.run. So run must automatically do the update, and instead I could probably manually call it update. Is that what you're saying? Like if I said this. So if I do this, nothing's moving. But I could say in draw, engine.update engine. So now it's updating once each time through draw. You can see that it's actually doing it a little bit more slowly based on, and I'm not having the overlapping issue. Oh, I got to come back. And then I could change that to, I could see if I, okay, hold on, where, I'm trying to decide. I want to add this to, hold on, Mathieu, watching this later. Putting it in draw isn't right? Oh, I'm not allowed to do that? Why am I not allowed to do that? I have to put in like set interval because I've really got to be perfect about everything? Is that what's going on? All right, fine, let me look at the documentation. Matter, well, engine, I want to look at engine. Engine, clear, update. By delta time milliseconds, the correction argument is an optional number that specifies the time correction factor. The value of correction is defined as delta, therefore the value of 1. Yeah. Triggers before update. Okay. Engine, delta, correction. Why is it in brackets here? That's just because it's optional. So really what I would put is the actual number in there. Why can't I call update and draw? I think I can call update and draw. Yeah, request frame. So you should use it, the after update hook, to redraw clearly. And there's a steps per frame. Yeah, you guys are giving me good suggestions. Let me look at the, what's the Matter.js with you? Some corners are still clipping over other rectangles. That's the correction thing. Okay. Okay, hold on. Mathieu, who will be editing this later into a single video. What I'm going to do now is I'm going to go back to some moment in time, right where I did this. And, okay. So, and I'm going to end, simply you do the logic, then you draw. Yeah, I'm fine with that. Okay, I will discuss the pitfalls with what I'm doing. Remember, this is like, the coding train was sort of a name, but I think actually I should just call this channel like bad practices in coding. Okay, so, okay. Okay, so before I move on and finish up this video, I do have one last thing that I want to look at. So there still is, even though I corrected the problem with the stuff isn't falling below the bottom, you'll notice that, as things fall, there's a little bit of like overlap, and it looks like there's some weird error things going on. So one thing that's happening is that I told the engine to run in setup, and it's running almost on its own, separately in its own world at 60 frames per second. And there's like a time step and how it's calculating, and I'm drawing in P5 in the draw loop. So I probably need to be more thoughtful about how I do this. So what is the frame rate of the draw loop? What is the sort of time step in the engine? And so one thing that I can look at, if we look at the documentation, if we go to Matter.js and click on engine, the function that I'm using is run. So I'm going to look for engine.run, and this just runs it. But actually, if you notice here, there is a function called update. So update is a function you could call for an individual time step. So I could use like set interval or request animation frame to trigger update myself some at certain moments of time. And I can also even alter it delta milliseconds, which is thinking about, and correction. So the value of correction is defined at delta divided by last delta. And it's a time correction factor, which I think would probably help in terms of this issue of things skipping over other things and the accuracy of the collisions not kind of overlapping. So one thing, I'm sure you could dig into this a lot more, but let's just investigate. If I take engine.run out, right, and I run this again, as I add rectangles, there's no physics happening. So, but I could make the physics happen by, I could say, this is like a terrible idea, function key pressed, if key equals space, then I'm going to say engine.update engine, right? I just want to update the engine manually. So I'm going to hit refresh. I'm going to add a bunch of rectangles, and I'm going to hit the space bar. That didn't work. Oh yeah, it did. So I'm hitting the space bar. You can see every moment of time is happening one at a time. So what happens over and over again? P5 already has its own system that behind the scenes, I believe, uses request animation frame or some other mechanism for looping. I could just say, hey, update the engine, draw everything. Update the engine, draw everything. And so now you can see it's actually running a little bit slower because the canvas animation is probably actually only running at like 30 or 40 frames per second. I don't know what it is exactly. But you can see, I don't know if it appears more accurate, but you can see I'm now manually updating the engine. So I have a feeling if you dig into this a bit more, read the documentation, think about it, and you could start to change the delta and the correction factors if you're experiencing certain issues. Okay, so hopefully that helps you understand a little bit more about Matter.js. We can make bodies using bodies dot and the kind of thing we want to make, rectangle, circle, and there are other things I'm sure. We can organize our code in such a way that we put this body, we kind of create our own object wrapper around the body so we can write our own display, show function. We can keep track of extra variables, like we could add a color variable. We could set certain options for it. And then once those bodies get added to the physics world, all we have to do is kind of render the stuff with our own designs. So this gives you kind of like a step into an inkling of using Matter.js. I will make some more tutorials about other features. I particularly want to make sure I look at the constraints of how to connect two bodies and interact with the mouse and also listen for collisions. All these things are important. And then maybe a couple coding challenges. So if you have some coding challenge ideas with the physics engines Matter.js, let me know. There's a link to the GitHub repository where you can suggest ideas and stuff. So thanks for watching this tutorial, and I'll see you in some future ones. Goodbye. Okay, I see that it says 6 p.m. on me, I am so me's last chat comment. So that must be 4 minutes ago, because now it's 6:04 p.m. And I'm going to get going. And I am still live. 1,000 divided by 60 frames per second is 16.666. That's right. Yeah. Because you don't display the stress, which Matter.js does. Okay, so thank you guys for tuning in to today's live stream. I will be back tomorrow morning. I hope to be back around 10:30 a.m. Eastern Time. I have been known to start as late as 11 a.m. Eastern Time, but I hope to have no technical difficulties. So I am going to finish up. People are saying good stream in the chat, which warms my heart enormously because I don't know, today was such a weird stream. I don't know if people are like whatever, but I do feel like we did get through some good material. In talking about physics engines. I made a nice little strange drawing of a face that's got some kind of interesting jowl action going on here. I hope that somebody actually makes this project, makes this face with a little physics engine skeleton. Quick, do all the suggestions in Rainbow Topics. I'm going to talk about the Rainbow Topics repository and some of its new features, and also the Rainbow Code repository and our new system for sharing community projects tomorrow. If you like what I do and want to support it and join the Slack channel for patrons, you're welcome to go to thecodingtrain.com and click on the Become a Patron button. And especially patrons who are watching, if you want to send me things that you'd like me to share in tomorrow's live stream, I will do that. Quick dance. I'm going to do the party parrot dance. What's the origins of the party parrot? I don't know anything about it other than it does something like this. You lost all the mentioned drama in the chat. Oh yeah, there was a whole lot of drama. What am I programming tomorrow? So tomorrow I think what I want to do is continue making some more stuff with Matter.js. Albert asked about the soothing random number reading. I'll definitely do that tomorrow morning. I'm also going to do, what I really want to do is cover geometry texturing. So how to create shapes with begin shape, end shape, and vertices, and then take an image. So if you send me your cute kitten pictures that don't have some kind of like copyright issue that I can use in my examples for tomorrow. And so that's what's happening tomorrow. Thank you, Germany, for watching. Auf Wiedersehen. What is my Mac? I don't know, it's some Mac Laptop Pro from a bunch of years ago. Hashtag Fleshgate, I think, is definitely today's hashtag. I should just leave my mic on you know, I could just like leave the live stream on. I could leave the mic and just go with it. And you know, eventually it would disconnect. The wireless connection would disconnect. Oh, you know what I really need to do? I really need to do my mobile live stream from my phone to walk through the recording setup that people have been asking me. My MAC address is, that would be bad if I showed my MAC address on the live stream, like somebody would do something about that. Let me not do that, okay? Oh, it ended. Okay, I'm gonna go. Thank you guys for watching this live stream. And I might, this live stream might get edited and uploaded as a separate video with a certain part edited out. I have to decide if I want to do that or not. So, but all the important, meaningful part. What I would like to hear some feedback on is whether that like overview of physics libraries was useful or not. I didn't feel it was that useful, and I would almost like to do it again. Okay, I'm gonna go. Yes, that's like A's Neon in the live chat is the best joke of today, which is like the library is p5.js. Okay, great. Thank you, Ross, for saying that. Okay, I'm gonna go. Thank you, everybody, and I'll see you tomorrow morning. I'm excited. I feel like this was a good warm-up act. I'm ready for tomorrow. It's gonna be a great live stream, and I'll see you all then. I gotta go home and have some dinner and go to sleep. Get a good night's sleep. Did not get a good night's sleep last night. Okay. Gomako, welcome. It was your first live stream. That's so nice to hear. And I'm excited to maybe hopefully show the Diastic project that you made. Okay. Good night, Jiraj and Fabian and Aditya and Heater Scar and all of you watching. Goodbye.